Hi, I'm Jason Crusan. I'm going to back up a little bit and give you a little bigger picture of how what you've heard today kind of fits into our overall human spaceflight architecture. So if we go to the first chart, what you're seeing here is a picture of how we move from today's capabilities as we're kind of working on the fundamentals at ISS and mastering those fundamentals. You see other capabilities are advancement of commercial cargo and crew to low Earth orbit. And over time, now you're seeing how that we move from this Earth-reliant phase, which has relatively short durations in order to get back to Earth, moving to this proving ground phase. As Steve described, the 9 to 11 day phase allows us to start testing our human spaceflight systems and capabilities in this proving ground on a pathway to move out to Mars, to what we characterize here as more this Earth independent phase. And you think about this in time duration of it takes for the crew to get home. And so it's really critical in this proving ground phase that we work on these capabilities. So I'm going to walk through this at a high level and give you some more details on that. So the next slide. So this is a chart that many have seen over the years that we've used. It's our capability-driven framework. I won't spend a lot of time explaining it, but at the basis of this slide shows as capabilities advance, new missions or mission classes open up. So what we're working on here with the asteroid mission is advancing critical stepping stones of those capabilities to start working on in-space propulsion, the SLS and Orion capabilities, the EVA capabilities, and we're actually being able to extend our duration of human spaceflight into deep space. And we're kind of walking up these stepping stones on our way to the ability to have humans into the solar system and onto the surface of Mars. On the next page, one of the things that we always talk about technical capabilities, but there's some guiding principles that we have to consider at the same time. It's not just building the right technical capabilities, but we have to be bounded by some realistic expectations or principles within human spaceflight. You'll see them listed here. Obviously, we're working within our budget with our modest increases that we have today. We're looking at how do we apply high technology readiness level solutions while still maintaining a portfolio of investments for the future that we need as well. Here you saw us tying together relatively high technology readiness level technologies into a mission application that's pretty compelling for us to start buying down some more risk towards Mars. We want this near-term mission opportunities, a constant cadence. We can't just plan to build for 15 years of systems and go launch it one day. We need to be able to figure out how do we buy down that risk over time, but through incremental, reasonable steps, and have that near-term mission cadence to do that. We need to do this not alone. We need to work with our U.S. commercial business and expand the lessons that we've learned with commercial cargo and crew and our overall logistics chain that we've had experience with there. But how do we expand that into even further markets? We need to stop throwing away hardware is really the point of number 5. How do you do multi-use evolvable space infrastructure? How do you use evolvable capabilities? Let's not build the same sensor sensor capability on multiple vehicles. Let's build one integrated sensor capability and use it across. Let's build one set of elements and evolve that element over time to the capabilities that we need today. And going back to the last principle here, we have a strong partnership relationship with all of our ISS partners and through our global exploration roadmap, the rest of the global space community. And we are then going to be leveraging them and working with them as true partners as we go forward with this. So next slide. So here's a simple way to take a look at it. As we move from this Earth-reliant phase, there are sequences of missions where ARM, as Charlie described, is one of those key linchpins, but it is not everything. There are multiple things that we need to do in this proving ground on our way towards being Earth independent and ready for Mars. So we go on to the next page. I'm going to give you a little bit of an overview here. This is our global exploration roadmap. This is not a NASA slide. This is a slide actually developed by the global community of space agencies. And what we're looking at here is starting with the principles of today, our strong international partnership, building upon that partnership, extending the life of station to allow us to maximize the utilization of station both for research purposes and commercial utilization, but also our risk reduction for exploration. Leveraging that capability, starting to think about, and as we are here today, how do robotics missions and human spaceflight missions work together? Not just at NASA, but in the global sense. You saw some of our key measurements before on which asteroids and which boulders you want to go contact. It wasn't just NASA missions to these asteroids. We are coupling the global community into these measurements on how do we work scientific missions along with human spaceflight. These are kind of our core principles then leading into sending humans beyond low Earth orbit and working in this proving ground on our way to Mars. So next slide. So people ask a lot of times, okay, what pathways are out there for us? I mean, today we're mastering those fundamentals with station. We're building that high reliable life support system, lowering mass of those systems. We're obviously bringing SLS and Orion as our deep space transportation leg online for advancing that. We have a high EVA rate when we did assembly a station, but we really need to figure out what is the EVA dynamics as we go into exploration, as Steve talked about. Autonomous rendezvous and docking. We're still going to have large-scale docking in these deep orbits that we need to be able to do. How do we advance that into common docking systems? So we're building on this high kind of fundamental heritage that we have, and now we're starting to push those boundaries from an operational perspective, getting into the deep space operations, trajectories, the radiation environment, the environments that our crews will work in. How do you do true robotic and human mission vehicle interactions and those complicated maneuvers that these spacecraft will have to do to work together, while still working on that advanced in-space propulsion and large object maneuvering. Even going further on our object maneuvering, if you look at maneuvering pieces of an asteroid or an asteroid itself, that stack size, the masses that you saw there, are similar to the masses that we'll have to manipulate as on our pathway to sending humans to Mars. So this will give us critical risk reduction there. And then this opens up pathways through Mars moons, working with our international partners in cislunar space as they proceed to international or potentially even commercial options for the moon, working together. So these are the critical elements that we're building on today to open up all these pathways as we go into the future. Next slide. So a little more specifics about what we're here for today talking about. This builds upon Steve's chart that you saw a little bit earlier. You have the core building blocks of what the ARM mission brings to the table. There's a notional piece in the middle. Through the BAA, we are actually asking for specific commercial and partnership opportunities of how we expand the relevance and extensibility of these systems to look at things like in situ resource utilization, additional asteroid sample collection, this lunar Mars mission scenarios. How do we enable this through these fundamental capabilities we have? The yellow box there is specifically the area where we're actually actively working with the BAA call that you hear about from Chris here in a little bit. But what are the missions that look like next after the initial human interaction with the asteroid? What are those? What should be the next capabilities that we're advancing and extensibility of those? So next slide. This enables that multiple pathway future from everything from this asteroid exploitation missions. Is it just one or is it multiple? Is it working with our international partners in the lunar vicinity to enable and work with their missions and contribute to their missions that they run in that area, to building the fundamental stack of vehicle capabilities that we are going to take to Mars. You see, what we're looking at here is fundamental capabilities that build upon each other. They're modular in sense, they're evolutionary as common building blocks, and we're not reinventing what we need every time. We're actually building upon our past and contributions that we've made both domestically and with our international partners in order to enable this capability-driven framework all the way to what Charlie gave us as the charge earlier today with humans and boots on the ground at Mars as our near-term destination. So with that, I'll turn it back over.